the 5 words. Oh,
Okay, I'm going to get started. So I want to welcome everybody tonight. This is the October meeting of the Texas DX Society. Here's our agenda. I'm calling the meeting to order now. Uh, Jim is going to take a few minutes and talk about the WRTC 2026. Uh, I have just a small request having to do with meeting invitation and the whole process. I'll give you just a very brief update of the Texas QSO party and where all that stands. And Rick Hiller will do his presentation on receive antennas. And we have a period of time, as much time as we want for questions or discussions after Rick finishes up, and then we'll be done for the evening. So, Jim, do you need to share a screen or anything to have your discussion on the WRTC?
No, I think it'll just be simpler just to talk a little bit about it. As some of you know, when we had the face-to-face meeting last month, we brought up the subject of WRTC since we'd had a speaker about that, and he mentioned sponsorships. At our lunch meeting, we talked about the fact that there were tent sponsor positions still left, but I checked this evening and there's only one left. And from what I understand, they're about to fill that. So instead of sending $1,200, no, actually $1,600. We get to make other choices. If the club wants to support this, at the $10,000 level, the gold level, which would only cost $13,300, or you could move down to silver, which is only 1,333 pounds.
Which is led.
Well, we're going further down. The bronze level is 500 pounds, otherwise known as $666. So that would be or at least my suggestion is that we go in at the bronze level. Also at the bronze level are a couple of other clubs of our caliber that have already committed at that level. I can't remember exactly who they were, but I recognize them, so they must be good. And on top of this, you can have an individual sponsorship, which only costs you £100, and for that you get a commemorative coin. So I understand from the speaker 2 months ago, one that talked about WRTC, that he actually has those coins so that you don't have to go through customs and probably pay a duty on that coin. So anyway, that would be, if I was going to propose it, that would be what I would propose is the bronze level, and we'll just see how the membership feels about that.
Okay.
I think it sounds okay.
How much was that again?
That bronze membership is 500 pounds, which on today's conversion works out to $666. So that would be now. I'm sure they would take a lesser sum if anyone was interested in that too.
K5WA and I split a tent, so you could split something if you
Yeah, but there's only one tent left, and the conversation I had earlier today is there were a couple of people arguing over who was going to get it. And it's the number 2 South America tent. So whatever that zone is. And by the way, you can bring up our WRTC, just use that WRTC 2026, and you can get tons of information from their website.
Quick comment. Club member K5WA Bob Burns is one of the participants in WRTC this year. He and N2IC are one of the North American teams. So, this is an opportunity for TDXS to, get out there and support the whole international effort of contesting. I've already contributed as an individual through a club up here, but I'd urge you guys to go ahead and try to support this K2TNO back to net.
So
Nobody's got
do we need to make a formal proposal, or how do you want to work this, Roby?
I think that's what we need to do. You make a proposal and we'll agree or disagree, and then we'll be on our way.
Okay, well, I would propose that we go in at the bronze level, which will cost the club approximately $666.
I second.
Okay. All four, say aye.
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 Aye. Yep.
Aye.
All
Good.
opposed? Okay. There we go. We got it. Thanks, Jim.
Okay, thank y'all.
Okay, the next agenda item, just briefly, what I try to do when I host the meetings, and I don't always host them, but I have is I try to I do send out the invitations to the TDXS email list, to the CTDXCC email list, and to the Tidelands Amateur Radio Society email list. I ask that this be forwarded to whoever might be interested, and I include meeting invitations when I do that. I get a fair number of emails from people about, would you please send, I haven't gotten an invitation yet, but they're on the distribution. So, I just kind of ask that you read it because the invitation is there. And if for some reason I haven't included it, I'm happy to redo it. It's not really a big issue. Just try to get it to as many people as possible. I had a short conversation with Rick Hiller about I have never been able to post anything to the BVARC list. So in the future, I have a path forward now to see how I might get on that list, and just trying to get these programs to as many people as possible, because I think that's the best thing to do. So, and if you know of anyone that might be interested in the kind of things that we that we do here, please ask them to get on one of these emailed lists. I think that will make life easier. There's a 6-meter group here in town that's just gotten started, and I also try to send it to them, but that's about 21 individuals, so that's a little bit cumbersome from an email perspective, but we still can get it done. So that's why I'm trying to make a plea to get on an existing email list if possible.
What email client do you use?
I use Chrome.
Okay.
Google.
Well, I Outlook that you can create groups. Maybe you can in Google too.
You can create groups, but what I'm trying to avoid is being the keeper of the list. I get tons of requests, and I have a lot of my own lists and things that I do. So I'd rather somebody join a club list than have me build another list to send it to them. So, and I'm going to work with Calvin to see if he can formalize something maybe with Groups.io with the 6-meter group. So we'll see. It's just a matter of convenience. Okay, so I want to talk a little bit about the Texas QSO party. 2024 is finally finished. I've been communicating with OM2VL and have confirmed that he has both his certificate and his plaque. So that was the last outstanding item for 2024. I made a proposal to Doug to get reimbursed for some of the money that I had spent. See if I can find my list here. Here it is. Okay, so we collected about $1,300, and actually just a little over, about 13, just under $1,300. And my expenses were right around $1,200. And I asked Doug to reimburse me for that amount, and I have receipts and all that sort of stuff. So basically, the Texas QSO party cost us about $40 from the club that we did not get reimbursement for. So that's pretty good. So for 2025 in the future, I have been working with Chuck in NO5W, and he considers himself the owner of the Texas QSO party. And we have another guy who is possibly willing to fill the role of TQP coordinator, and we'll be having a discussion about that in the next few weeks to put together a leadership team for 2025 and beyond. Chuck has agreed to do again the scoring and all that sort of work for 2025. So this new leadership team, when they're in place, will decide what if any changes they're going to make and how they're going to handle 26, 25, 26, and in the and into the future. So we will hear from them whenever they make their decisions. So that's kind of the status of the TQP. We got lots of positive feedback. I did directly from a number of people, and other people have gotten positive feedback and had forwarded that to me about the TQP. So it has a pretty good following, and I hope we can keep it going. I'm sure we'll be able to do that. Okay.
Quick question.
Yes.
A quick question, Roby. How did Alpha Delta 4 Echo Bravo do? I couldn't make it into the contest this year, but he and his wife go around and normally make a big play for that contest.
So he won. He won his category, and he worked with. He asked Chuck for special recognition for his wife, and so his plaque and his certificate both list. I can't remember his wife's name right off the top of my head, but they list both him and her as participants, and I think that's exactly what they were looking for. So I think we did the right thing there. They seem to be pretty happy campers about that.
Yeah, very good. Last year he won, and I sent him a framed Wick Feller's 2 alarm chili box in a box, and he and his wife have that on in their den on a bookshelf.
Yeah, and I think the I don't remember the exact number of logs that have come in, but it's approaching 400 for 2025. And from what I had seen, he's probably going to win his category again, probably by a pretty significant margin, which I don't think that's any surprise to participants. I worked him a bunch of times, so it's pretty cool.
Yeah,
Okay.
I'm gonna send him, just for the hell of it all, I'm going to send him another box of Wick Fowler's 2 alarm chili box.
Cool.
No beans.
Okay. Rick is going to give us a presentation on receive antennas. So whenever you're ready, we'll turn it over to you, Rick.
Okay. Let me gotta find the share button. Whoops. Okay. So
There we go.
I need to why doesn't here we go. Okay, can testing 1, 2, 3. Everybody hear me okay?
Yeah.
I guess.
Yep.
Yeah.
Looks good too.
Okay. Well, very good. Well, a few months ago, Roby asked me if I'd be willing to do a presentation. I said, sure. How about receive antennas? So I started looking into receive antennas, and that is a hole in the ground that is very, very deep. It is, you think receive antennas, oh yeah, receive antennas, only a few and so forth. It's incredible. And I hope to keep this interesting and high enough level to keep your interest and get you to maybe do some additional research after this to look into one of these antennas or multiple antennas to make your station better and improve your station's ears. One thing I did on this presentation, I usually have a blue background with yellow text, and I decided that I was going to allow AI that comes up in PowerPoint to help me with the presentation. So the backgrounds here, like this one here with the dishes, was AI's not AI's fault, but that was its input to this particular slide. So if you see something that's, oh, that doesn't look right, it's because of AI's fault. So I'll blame it all on AI. So okay, that didn't work. There we go. So I have a disclaimer right up front. We all know transmit antennas. Everybody deals with those dipoles, Yagis, loops, things like that. And we understand them right off the bat. So forth, but we know how to analyze them. We know how to model them and so forth. But I looked into this receive. I have got a pile of books here all about receive antennas, and there is some information in here that's just way beyond my knowledge level. So there's just a tremendous amount of information, and trying to reduce that to something reasonable for a short presentation was a little bit tricky. So hopefully I've done good. 2 publications that are in this presentation was the ARL antenna book, the 25th edition, the chapter on receive, and then the ON4UN's low band DXing, which is my go-to for pretty much anything. But Tom, WHAI, wrote a 100-page chapter on receive antennas. And for the antenna handbook, I bought the one that was separated out and so forth. And I've got a bibliography at the end that shows you everything that I use and referenced, so you can do that too. Like I said, the 100 pages within the low band DXing is just tremendous. It goes everything from why we use antennas, the noise reduction using simple antennas, circular arrays, end feds, rectangular loops, preamps, and so forth. It's just incredible. It's inundating. It took me a long time to go through the 100 pages, and hopefully I parsed out what I needed. But using separate antennas, we can improve the ears on our station. Found this photograph years ago and always wanted to use it. Well, I used it tonight. Okay, so transmit antennas, their goal is to get all of the power from our transmitters efficiently out into the atmosphere, into the ether. That's the transmit antenna. Somebody's flushing a toilet. On a receive antenna.
That's another type of receiver.
That's another, yeah, really. But on a receive antenna, its job is to provide our receiver with the best signal to noise ratio. So there are 2 different requirements. Although they do look similar in their analysis and so forth, it's a different way to look at things. Reciprocity, we use that term with our antennas, and that's one of the cool things about our antenna. Most of our antennas, the patterns that are produced on transmit and so forth are exactly the same patterns that an antenna has on receive. But that unfortunately doesn't work so well on the low bands because there's a terribly raised noise floor, typically a band noise, and there's omnidirectional noises coming from all sources, which are messing with you. On transmit, you can get around that. You just point everything in one direction and go. Whereas on receive, you're taking everything in. So reciprocity doesn't particularly work on the low band antennas, but it is still a capability that we like to have for sure. So why separate receive antennas? They can provide a better signal to noise ratio. That's why we're using them. They optimize intelligibility so you can understand the station that you're trying to copy through the QRM or the QRN or the local air conditioner from your neighbor. And typically receive antennas are smaller in size than a full size. You don't need to put up 200 and some foot dipole for 160 meters because that's on the transmit side. On the receive side, you can put some type of small loop and so forth, depending on what you're trying to do. So the receive antennas have changed over the many years, but ham radio receive antennas for the lower bands were typically small loops like you see here. If you go back in QST, you'll find that Doug DeMaw, W1FB, put one of these designs. Typically gives the pattern that you see on the diagram on your right, and that's what people were using, and that and possibly the beverage, because I go into this a little bit, but the beverage, it was used and then it lost favor and nobody used it for a long time, but then it got back into being used. But anyway, we'll go. But one thing Doug talked about in one of his books was that have a separate receive antenna on any band is to just choose another. If you have multiple antennas, just choose another antenna. It doesn't have to be resonant, doesn't have to be matched, but it could be advantageous for the pattern it produces on that particular band. Roby, you were saying to me that your T8 log periodic works as a great receiving antenna on 30 meters.
Absolutely.
Yeah. So
I've really been surprised.
So, I mean, that's one easy way to have a separate receive antenna. One that I used years ago was a helically wound short dipole. He recommended getting some dowel and winding a dipole. Doesn't have to be resonant, doesn't have to be anything, but then bring it into the shack, do a little bit of a tuner, and see what that can do for you. It's simple, it's cheap, and so forth. Another thing that I used, and he recommended, and there was an article in QST years ago about the snake antenna, where you just put a single wire out there. It's kind of like a beverage on the ground, but not, or a beverage right above ground, but not to that extent of an analysis. It was just lay out the wire and see what it does. But it's simple. It's a second receive antenna, or I should say, it's a second antenna used for receive. So where it all began down on the ham bands years and years and years ago, back when I don't think anybody was born back then, but it might have been. Hams were using very, very low frequencies, but also being used at those frequencies were the commercial versions. All the traffic coming across the Atlantic and to different continents was Morse code, either Morse or American code, whatever. And each company, for example, RCA had a gateway station that would receive and send these telegrams and so messages to various continents. And that's where Harold Beveridge started out. He started out at Riverhead in Long Island. And not only did he do the Beveridge antenna, which we'll get to, but he also had multiple Beveridge antennas feeding multiple receivers. So diversity reception, he found, was also another method to have better receive capabilities. The commercial traffic, like I said, it was a gateway on every station, and I have a book right here. It's called Genius at Riverhead. It's a profile of Harold H. Beveridge. Tremendous book, tremendous story of Dr. Beveridge, and what he did years and so forth ago. But the cool thing that stuck out was that he experimented with antennas that were 2 miles long and very, very close to the ground, a fractional wavelength to the ground. They weren't 6 inches or so, but they were on telephone poles. But at those frequencies, that was pretty close to the ground. And he found that those wires coupled very well, and he put multiple in parallel and fed them to diversity and voting type receivers, and that way they could keep their path to the other continents where they were going open, because if the paths were open, they were sending traffic, and if they were sending traffic, they were making money. So I've been to Contest University up at Dayton. Didn't go last year, went the year before, and one of the presenters was Frank Donovan, W3LPL. He gives a bunch of presentations, and some of his stuff is just incredibly intense. And you'll see some of it because I've used it a lot in this presentation. Most of his stuff is 80 and 160 and so forth, but one note is that even on the higher bands, which I have a problem here at the house, I've got noise, electrical noise and so forth that I have to deal with, and I'm trying to figure out what antenna can help me eliminate. Anyway, Frank's presentation has been pretty much copied there. He outlines this very, very well. He's done all the research, and hence that's why I'm plagiarizing his talk. Giving him credit, of course. He's a very nice man, very great station up there in, I know it's Maryland, Hagerstown, right outside of Hagerstown, Maryland, I think. So anyway, one general thing that I found in researching it says, so it seems that as the complexity of the receive antenna system increases, so does the amount of landscape that's required to implement it. and possibly money too, but I noticed that in there. Well, a small loop sitting in your shack, like Doug DeMaw had, that doesn't take up much room, and then maybe the K9YA shared loop, that doesn't take up much space in your backyard and so forth. But some of these 9-element vertical arrays, they're a football field. So, but like I say in this little joke here, it says it takes a field. So it does take a lot of room for some of these bigger ones, although the performance is worth it to some. So it's nice to look at, and it's kind of like being able to only put up a dipole, but knowing what a 5-element Yagi at 75 feet will do for you. You can just drool over that. So here's Frank's presentation. This is his first slide. I'm not going to spend a lot of time, but he goes into why the receiving antennas. First off, they're lower in cost. They're smaller. You can keep them lower to the ground. Most of them are very low to the ground. For example, the Beveridge is always low to the ground, and one of the reasons is they don't want any horizontally polarized signals coming in from the side, so they keep it really low, so it's, quote, below the radar. And he said that all his receiving antennas that he shows in here, which are many, 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 can be scaled down to 80 meters if they're on there for 160. So I found that this is new information to me because I hadn't really studied receive antennas, but there's 2 methods for quantifying the performance of a receive antenna. One is the RDF, the receiving directivity factor, and the DMF, the directivity merit factor. These are defined as such. The directivity merit factor, it compares the forward gain at a specific angle to the average gain over half of the hemisphere that's plotted. And on EasyNet, you can plot the main lobe out, but you can also see the back. Well, the DMF compares those. The received directivity factor was generated and invented by Tom, W8JI, and it compares the forward gain of that same elevation, angle, and direction to the average gain over the whole area around the antenna. And that's the more preferred method to do this. And it comes up with a dB number. So your antennas are rated, and you'll see in the charts that I'll show you. So the RDF, which is going to be used in this presentation and Frank's presentation, I should say it's at the desired angle, the elevation angle. EasyNet can be used to compute that RDF. It assumes noise. Apparently, it's an invalid assumption, but it assumes noise is equally distributed over the entire hemisphere. So, and it points out a few times that any kind of near field stuff is not accommodated for. Everything has to be in the far field in order to be considered under this received directivity factor. So it's got to. So, and you can see this here. You see a pattern, whereas you see the max gain at the small blue, and then the overall area around the antenna is in blue that's measured. And those two are compared for the RDF. So there's a bar across the top of my screen, and I can't see what that says. And it says these are
small receiving antennas, 4 to 11 dB RDF.
Okay. That okay. Thank you very much. Yeah, I can't see that. There's this thing that says this meeting is being recorded. No kidding. So this shows some of the simple antennas. This is an 8-foot diameter magnetic loop, single vertical. And you can see the RDF over there starts 4, 5, 6, 7. The beverages start to add a little bit more.
There's an OK button on that thing about recording that'll once
thank you.
OK, it'll go away.
Well, I didn't want to push the button and then have the whole thing die. But it doesn't go away. It comes up with another bar, but that's okay. Thanks very much. So then that's the RDF starts to rise when you go into the unidirectional terminated small loop close to the ground, like flags, pennants, U's. Ooh, goodness. So here's an example. This is a U. Roby was telling me today that he used a couple of these. They may not be configured as such, but this was popular quite a few years ago when U's and flags and pennants were all over, written in QST. But it's a fairly simple antenna to put up and use. There's the flag antenna. It's a terminated antenna. These are small enough, and some of them are small enough, especially the pennants. You can make them small enough that you can put them on a pole and rotate them, and that. But they're pretty simple to use and build, so forth. You see there's an increase. You can see what the RDF is on these antennas for the unidirectional terminated small loops. Sorry. Flags, pennants use 9AY. We'll get into the 9AY. And interesting, at the bottom, it says small antennas are the best RFI reduction antenna when RFI sources are within 1,000 feet in the quote near field. So that's something to think about. If you've got some type of interference, maybe the smaller antenna is the way to go. And I can't, again, this is a magnetic loop, the small loops that sometimes, if they're big enough, they're used for transmitting. They're about 1/10 of a wavelength long. You get down into about 300ths of a wavelength, 300ths of a wavelength long. Then they start to be a receive antennas. One thing is, halfway down here, it says that small loop antennas produce very low signals. That's pretty much the the same for all of these receive antennas. The signals coming out of them are very small, so you do need some type of amplification. Sometimes the 20 dB preamp in your transceiver might work fine. Others, you may have you need to have a separate preamplifier in order to get that signal up. But because you're looking for an increased signal to noise ratio, you're looking for the antenna to lower the noise. But when you lower the noise because of the pattern, you may also lower the signal that you're looking for. But the differential reduces also. So yeah, both signals go down. The noise goes down even more. And then with the preamplifier, you bring both of them up.
I'm in a meeting.
However, it makes the signal you're looking for intelligible. So let's see. This is an example of a receive loop K6 STI. This is written up in many locations. It's available online. He also has an amplifier that he's put, well, not an amplifier, but an interface to interface to that. And again, that's stuff available online. Small loop K9AY has an RDF of 8 to 9 dB. It's quite good, and they're quite small. My friend Jeff, A0ST, has one up in Missouri that he just bought a couple of months ago. He speaks very highly of it. You can buy them. I think he bought his at DX Engineering for, it was under $1,000. I don't know how much under, but you can buy those. This is the small loop that Doug DeMaw had, but there's many of these out there that you can buy and use just for receiving. Some of these are used for transmitting also, but does pretty good. It's got a 150 degree figure 8 bidirectional pattern, 3 dB beam width. It's not great, but it does give you some type of reduction, and it's fairly simple and fairly cheap to do. So again, the receive antennas run the gamut of simple to complex to little to large to cheap to expensive, just like our transmit antennas do. This is the Waller beam. It's two, I'll show a schematic here in a minute, but it's two squares that are fed and so forth, and it does very, very well. You can see, here's the thing, you can see the Waller flag there with two squares all fed and combined in the schematic. You can see the pattern over there on the right-hand side. It does fairly well. It's got 11.5 RDF, not bad, and it looks maybe a little complex in putting something like that together mechanically, but it can be close to the ground and do very well. Can be rotated. That's a benefit of that. The K9AY loops are, they have a system, so it's 20 feet by 25 feet, or the larger ones 50 feet by 50 feet. They're 25 foot tall. You can switch 4 directions, 8 directions, and they produce, again, the very low signals. You have to accommodate for that, but they speak very highly of those shared loop arrays in everything that I've read. So this shows the base of one. It does take up some real estate. You can't have cows underneath it or anything. It's pretty low to the ground. So, but if you have the space, it's fairly reasonable and does a good job. There's a picture of one from the side, and then Array Solutions offers a kit. DX Engineering, I said, also offers a kit. You can put those up and have 8-direction receive loop on your property, improve your receive capability. Gary Breed, the guy that invented the thing, this is online. This is just one page, but he has a complete description of how you can build your own and what you need to do, how to tune it, and things like that with the amplifier and so forth. So it's pretty good. A lot of this stuff, it just if you want to build it, you can. the information's out there. It's like any other ham radio stuff. If, there's commercials available, but if you want to build it yourself, you certainly can. Okay, now Frank goes into the high end stuff. The first one is 500, 600 foot beverage, about 7 feet high. That's getting closer to what Harold Beverage was doing. He's got close space beverages, Waller flags, 4 square array. He's got the tri-band arrays from a Yankee Clipper contest club, and down to the Endfire arrays that are 14 dB of the RDF, and that's quite good. But look at the size; it's 800 feet by 330 feet, and you certainly won't find that on a house lot here in Houston. Well, not in Sharpstown anyway. Let's a bit about the beverage. It seems to be gaining more in popularity. It has, Harold did a whole lot back then with what he had available, which is very impressive to me. So that's just his single wire, and you can see that there's a lot of analysis has been done on these that's available to see. Okay, can I put one that's 300 feet long or 600 feet long or whatever, and you can see the different of those lengths and so forth, the beam widths, and all of this analysis is available online if the beverage is what you'd like to use. Now this is beverage on the ground. They are, well, it says that beverage on the ground, but they're not on the surface of the ground. They're up about a foot or so, and they seem to do very well. Jeff AA0ST had one of these, but he actually buried it. He was in Dickinson, and he said it worked okay, But right at the bottom in the red says the beverage on ground. They're low sensitivity, of course, but they do require suppression of common mode signals on the coaxial cable feed because its coaxial cable feed is typically coming out of the ground. So choking that at the feed point and then choking it before you get into the shack is probably a good idea. There's another one. Look at beverages. Staggered beverages go up, and the RDF goes up quite high. Broadside beverage arrays, 2 beverages or 4 beverages even, up to the 12 and 14 dB RDF. And the beam width definitely reduces and provides you with good performance. But again, landscape, that's what you need. It was interesting that I'm a bit of a history nut on antennas and stuff, and this was the picture of the antenna that was used in the transatlantic test back in 1921, as you can read. And that's what they used to talk across the Atlantic back then at those low frequencies. But anyway, I didn't see anything. It said that K1PBW introduced introduced the beverage to 160 meter DXS. Couldn't find anything on that specific thing, so we'll just have to take Frank's word for it. Next time I see him, I'll have to ask him about that. If you're interested in the beverage, there is a book online called The Beverage Handbook, Beverage Antenna Handbook. Victor Misek, it's online. It's a PDF. It's I don't know how many pages it is, 30, 40, something like that, but it's all types of things that he's done with the beverage experimenting and different configurations and so forth. It's well worth the download and the read. I've had that book for quite a few years. It's pretty good. So again, Frank, W3LPL, wrote something on a Siku contest reflector I picked up years ago. This is available also online, information about beverages and how long they are and what frequency and so forth. It's interesting. It's kind of a funny comment. He said, right in this, people say, 75 meters. He said, why do you refer to 80 meters as 75 meters? He said, 300 divided by 3.75 equals 80. So there's always a big fight on Beavark, the rag chew net, whether that's a 75-meter net or an 80-meter net. So, all right. This shows the beverage on ground. It shows the feed point and so forth, but you can see the height of those wires above the ground. So it's not something you can use in a field where you've got livestock or so forth. But the RDS 6 to 8, that's pretty good for only 225 feet of length. Not bad at all. This is a patent that Beveridge put in for a dual direction. And that was done in 1922. So a year after he put in his original patent, he came up with the dual direction. And that's not bad for somebody back in 1922, in my book anyway. There's a pattern. This is at a 4 NEC, if you know that antenna modeling. It's pretty cool the way it comes up with the colors and the 3D and so forth. But it shows the, you'll see others further down that show some really great nulls for those antennas. But that's a 600-foot Beveridge, and you can see what the pattern is, one or two directions. You'll see that Beveridge came up with, again in 27 with parallel, but he came up with variable phase controller on that situation. I mean, that's the guy was thinking, that's for sure. Stuff that we almost take for granted now, he was doing 100 years ago. Let's see, there's 4 beverages. What an interesting array. They're 800 to 900 foot, and they're the length of a football field wide, or wider than a football field. So that takes up a fair amount of real estate, but it's only got a 45-degree 3 dB beam width, which is pretty good. Okay, let's look go away from the horizontal wires. Let's go to verticals, which are different. Again, they're still compared with our RDF, but most of the verticals are 20 or so feet. Some of them don't use radials, some don't use umbrella wires, which are the top loading wires you typically have. They're high. They have high impedance amplifiers at the feed point under each, and the switching systems allow you to switch the system to 8 or so, depending on how many elements you have. You'll see in a few slides. But High-Z down at the bottom, that website, High-Z Antennas is a good place to go for looking at any kind of high impedance or antenna like that is described here, I should say. Few people have used this. You can adjust phase between 2 antennas to null out noise. It's not the greatest, but it does work in certain situations. So you can have a source antenna and then a sense antenna and adjust the phase between them and get some advantages out of that. But that's available from DX Engineering, so you don't have to worry about feed line lengths and so forth and so forth. Everything is done inside the box. So this is a 2-element array of 20-foot verticals. That's a pretty good null down there on the left side on the y-axis, and that's a switchable, and it's not too bad. Certainly, you can give you a bit of an advantage on receive. This is he's looking at 20-foot verticals active and 25-foot verticals passive, but the 25-foot verticals are monoband only, and they do need 35-foot radials and 4 umbrella wires. So there's a lot of stuff up in the air on the ground with this type of antenna. And this is a 4x4 array. It's a 4 square, and it does a good job. It's fairly reasonable. It's cheap to put up and so forth. So you don't need a whole lot of real estate, but it's 80 by 80 foot square. Not too bad. And it's got a good. It's switchable into 4 or 8 directions depending on how it's configured, but you do have an RDF of 12 dB. So you have a good null there in the direction you're looking for. Now here's the big one. This is 8 high impedance 20-foot verticals. I mean, it's at the base of it, it's only 200-foot diameter. So it's still a pretty substantial piece of real estate in order to get that. But you do get 8 directions, 50-degree beam width. That's pretty good. So again, that's High Z Antennas has a description of that if you go to their website if you're interested in doing something like that.
It really works.
Yeah?
Yeah.
Oh, good. Yeah, it had good comments. You know, some of the places you go to, they have reviews, you might say. So I appreciate that comment. That's good. Good to hear. So takes a lot to put one up, I'm sure. You know, that's yeah. I'm sure that's the other thing. So, and there's the pattern there. Does pretty well. You can see that the down at the bottom, and it shows you what the pattern is for them. Let's see. So this is a steerable 4-square. So that depends on the implementation, but that's 35-foot radials on each, and again, the switching provides you with the beam width and the switching and going around the compass. You know, but let's see. And this is an 8 circle vertical array. It's got, I think, the highest RDF, but it's on 4 acres. So you have 8 25-foot umbrella verticals. So they all have top wires and so forth. So again, it's quite an extensive piece of real estate, extensive amount of wire and vertical poles and so forth. But it says it's very easy and inexpensive to build. So I guess that's, but that's W5ZN, and I don't know where he is or she is. I don't know. Might be close. Yes, ma'am?
It's a him.
Ah.
And I can't remember his name.
Yeah. But I've seen that call sign in many of my things that I've looked up online. So,
yeah.
So anyway. Okay, so we're kind of at the end. I mean, that was really high level stuff. I mean, you could dive into any of these antennas and just spend hours researching and analyzing and so forth. But you can do that with even on transmit antennas. So receive antennas have seemed to have evolved over time. We would have never had this plethora of antennas back in the 50s and 60s. A lot of the tools that we use to analyze the antennas weren't invented until 10, 20 years ago. But it's tremendous. But as you've seen, antennas can go from beverages that are 800 feet long and there's 4 of them side by side, or you can go to a hula hoop size loop sitting in your shack or right outside your shack. And one other thing that goes along with improvement of the receive antennas and getting them to perform the best they can, no matter the size, is the receivers we have. The receivers we have just increased in capability tremendously. They're more sensitive. They have better analog filtering. Now, with the SDRs, they've got digital filtering and high-end signal processing. And I don't do any FT8 or 4 or anything like that, but I was involved with seismic stuff, oil exploration years ago, and they were recording signals that were below the noise, and I think the FT modes also can record signals that are below the noise. So it's kind of like, well, do we really need receive antennas? If you can see them below the noise, then why do you have to reduce the noise? I don't know. That's one question I have for this. But and one thing we can't change, we can deal with propagation, but we can't change nature. We can't, make things better and lower noise and so forth. We have to apply more transmit power, different modes of modulation, the noise eliminating receivers and noise eliminating filters and noise eliminating antennas and signal enhancements tool, both analog and digital, in order to deal with what we're dealing with as far as propagation of noise on the bands and so forth, in order to have fun. And it's, all of this is, why are we doing all this? To have fun. That's what it's all about, in my mind, anyway. So I wanted to point this out. I don't know if you're familiar with this fellow. This was done at XZ. I know you know this guy. Chuck Councilman, he came up with an article about chokes, and you can Google this. It's on the Yankee Clipper contest. He went and he choked every wire in his shack, everything. Not only antennas, but control cables, power cables. Over time, he choked everything, and he found that the noise floor in his shack that he received reduced. And it wasn't like turning on a night switch, but over time, as the more he choked, the more that noise floor came down. So again, that was for fully generated stuff, but still a noise problem that can be solved fairly simply. I think, Alan, you might comment on this. We bought the cores, and then somebody came up with the Teflon coax that was used on this. Man, that was 7-8 years ago we did that, Alan. So I don't know. So it's just another part of this is all noise reduction. That's another solution. Okay, so this is what I used to put all this together. I know it was quick and very high level, but we didn't dig into anything in particular, but just to wet your whistle on a lot of receive antennas. Like I mentioned, the ARL antenna book, the low band DXing. The other ARL book that's by Eric Nichols, Receiving Antennas for the Radio Amateur, is quite good. It's quite good. Roby mentioned that this afternoon, but I also have a copy that I've read through. These books, they approach things in a different way. The receive antennas for the radio amateur, I described it as sort of describing receive antennas in a layman's term, whereas low band DXing, Tom really got into the nuts and bolts and equations and so forth about it. Antennas Mastered is a Radio Society of Great Britain publication. Peter Dodd, there's an article in there about used, but there's also other articles in there. It's kind of like the English version of the ARL Antenna Compendium. It was a good book. Receiving Antenna Handbook. Don't let the title fool you. There is one chapter, 11, that's receive antennas. Everything else is regular dipoles and loops and all this stuff. But it's called the Receiving Antenna Handbook. I just happened to pick one up at a Hamfest and used the chapter 11. The chapter 11 is on small loops, and it's quite informative. Also, the Contest University. Well, you saw I used Frank Donovan's presentation as a guide, and just Contest University. Go to their website. All of the presentations ever since they started are on there, and they're all just fantastic. You can go through, you can download them. They're PDFs, and you can keep them and use them, and so forth and so on. The other thing I did was I used the internet, of course, and I used ChatGPT and Microsoft Copilot to do what I had to do. And then I mentioned the book for Beverage was Genius at Riverhead. There's a couple other books I mentioned about, well, maybe I did mention, but there's a book by Art Collins that's all about what he did. Dr. John Krause, he was the guy that did the W8JK closed space 2-element array. He also invented the helically wound antenna, and he was the one that put together the big ear up at University of Ohio. And that's a good book. That's an autobiography by him. It's quite interesting. So, and all these guys were in the teens and 20s and 30s when a lot of this stuff was solidified, and and they were all hams. So they went from being professionals and they put that into their ham, or they were hams and they put that into their professional field, and it made them better at what they did. So anyway, that's all I have. I hope I did some generated some gray matter thoughts about going after receive antennas, because there's plenty of them out there. Go build one. Thanks.
Thanks, Rick. Questions, comments?
Hi, it's Glenn. So I started getting ready to put in a loop on ground, KK5JK, 15 foot on each side square.
Uh-huh.
This is a little binocular inside of this little bitty binocular core. I think it's the BN202-73 with, I think, 3 turns primary, 5 turns secondary, or 2 and 5, I forgot, or 2 and 6. But that's my next experiment. So I'm getting ready to do it. So it's on KK5JK, I think. Hold on a second.
That's it. Okay.
KK5JY.net. KK5JY.net. And he's done a lot of research on this little thing and the little antenna, and it's stapled to the ground with stables on the ground,
cool.
So you can mow over it.
There you go.
So, if you know, for 160 and 80, 75 meters is what he thought it most useful for, using the preamp in the current receivers, not requiring external preamp.
What do you feed it with, like
RG6 or RG 58, whatever impedance you decide for on the input.
Cool.
So and he talks about whether it's the primary is 2 or 3 turns for 50 or 75 ohms, and then the secondary, I think it's 5 or 6 turns. But it's in his article online, and I built 3 of these, and in a little weatherproof, waterproof box that was on eBay or on Amazon.
Right.
And it's one of my next projects after I rebuild my hex beam that got destroyed in the microburst that hit Austin in May. Yeah, 80-mile-an-hour winds for a few minutes.
So I'm a big experimenter. I've used K9AYs. I'm currently using 2 U's. I've used beverage on the ground, both elevated slightly, like we talk about, and actually just lying on the top of you're just lying on the grass. What I have found is these antennas work, but the real benefit of this is having an alternate. So if I'm listening on 160, I can use my inverted L, or I can use one of these receive antennas, and I can switch quickly between the two and use the one that gives me the best chance of making a contact. So, what I have found is a receive antenna is not always better than the standard transmit antenna. Sometimes it is, and the ability to go between them is really what, in my opinion, what makes a difference to use the best one. And Rick had made the comment earlier about my Tenadine log periodic and how well it works on 30 as a receiving antenna. That was just because I had the antenna switch in the wrong position one day, but I was able to copy stations that I couldn't copy on my vertical or on the other receiving antennas that I had. So it was an experiment, just an accidental thing, but again, the ability to experiment and try and see what works really can be helpful to you. And the idea, at least from my perspective, is to get that new one in the log, or that's kind of my motivation. But these things really do help. I'm fortunate. I have a little more space than a lot of people do. I have approximately a half an acre that I can kind of put antennas on. So I can't get my beverage on the ground oriented in the directions I'd like it to, but but there's compromises everywhere, right? But I would encourage you guys, if you're to experiment with some of these. The only caveat that I would offer is, particularly if you run power, be careful because your transmit antenna will be close to your receive antenna, and you can put significant power into it if you're not, if conditions work. And there are devices that you can buy that are, basically limiters, clamps, whatever you want to call them, that'll prevent it from damaging a receiver. But particularly if you run the full legal limit, you might have some issues. I run about 500 watts, and I use a limiter. But when if I'm running 100 watts, I have never used it. I didn't find the limiter to be of any great need for it. But if you guys have questions of me, I'm happy to share both here and otherwise on some of the experimental work that I've done, and maybe I can help you out.
I want to make a comment about the NCC2 that you showed. That is a great box. It really is. And it doesn't just eliminate noise, which it can do that. The knob on the right side, the big knob, changes the phasing of any two antennas you put in on the back of it. And if you have a receive antenna, then you can put that on one side and put your transmit antenna or any other antenna on the other and change the phasing. And actually, you can have diversity reception with it. The NCC1, the prior version, actually works a little better for the diversity reception. So I've got one of those here, and I planned that 8-circle array also has a smaller version, a 4-element version with the same gain. You just don't have quite as many directions. So I've got one of those. I've got a Sal 30 and a couple of 500-foot beverages. So I'm going to select those and apply them to the two with the switch to the two terminals in the back of the NCC1 and use that for diversity reception. So I think that's going to work really, really. Well, I'm out of here, men and ladies. We'll see y'all next time. Enjoyed it very much. Thank you, Rick. That was great.
Thank you. Appreciate that.
Cool. So just before we close, just a general comment I put out on the TDXS list in particular, and probably on some of these others, a list of topics, about meeting topics, and a few comments about those. Take a look at that and give me some feedback. I got pretty significant feedback from John K5IZO. Our next meeting of this type will be in December, and Bill K9HZ is going to talk about modeling of vertical antennas. And so that should be quite interesting. I've asked him in particular to talk about modeling radials close to the ground or in the ground or on the ground or whatever. That's a big issue. And looking at and helping me understand, or helping us understand more fully, how the modeling software can give us an idea of the antenna's overall efficiency. So there's a number of other potential topics on that list. So if you give me some feedback on that, if there's topics that you'd like to have discussed that are not there, I'd appreciate that kind of feedback. And what I really would appreciate is somebody willing, like Rick has done, to pick up one of those topics and put together something on it so that we can all learn. I typically find it's best for myself to tell you, I explain it this way: I'm going down this path in life, radio included, and I'm more than happy to share what I learn along the way. And if there's an experiment that you've done or piece of equipment you've used or something that you have tried and been successful or tried and not been successful, whatever that you'd like to share, that would be great. That way we can all benefit from it. Okay, anything else?
Thanks, Roby.
Okay. I appreciate all of your attention and attendance and attention tonight. Thanks.
Yeah, thank you, Roby. Appreciate it.
Roby.
Thank you all.
Have a night. Have a good one.
Thank you, Rick. Thank you, Roby.
Oh, you're welcome.